Have you ever wondered what makes our phones smart, our cars drive themselves, and our computers compute? It's a question that delves into the very heart of modern technology. Every time you swipe your screen, send a message, or even ask your virtual assistant a question, there's a hidden force at work. This force is not visible to the naked eye, yet it orchestrates the symphony of our digital lives with remarkable efficiency. The answer, in a nutshell, is the microchip. These tiny, unassuming pieces of technology are the unsung heroes of our digital age. They are the silent workers, tirelessly performing billions of calculations per second to ensure everything runs smoothly. These tiny squares of silicon, often smaller than a fingernail, are the brains behind almost every electronic device we use. Imagine the complexity packed into such a small space. Each microchip contains millions, sometimes billions of transistors, all working in harmony to process information at lightning speed. They process information, store data, and control the flow of electricity with incredible precision. This precision is what allows your smartphone to recognize your face, your car to navigate traffic, and your computer to run complex software applications. The microchip is a marvel of modern engineering, a testament to human ingenuity and the relentless pursuit of progress. Without microchips, our world would look radically different. Imagine a day without your smartphone, your computer, or even your coffee maker. The conveniences we take for granted would vanish, and our daily lives would be far less efficient. The impact of microchips extends beyond personal gadgets. They are integral to industries, healthcare, transportation, and even entertainment. Microchips are everywhere, from the obvious gadgets like smartphones and laptops. These devices have become extensions of ourselves, tools that enhance our productivity, connectivity, and entertainment. But the reach of microchips goes much further, to the less obvious places like washing machines, traffic lights, and even coffee makers. These everyday items rely on microchips to function efficiently and reliably. Your washing machine uses microchips to optimize water usage and cycle times, while traffic lights use them to manage the flow of vehicles and ensure safety. They are essential components of the modern world, quietly powering the technology we rely on every day. From the moment you wake up to the sound of your digital alarm clock, to the time you set your security system before bed, microchips are at work, making your life easier and more connected. But have you ever stopped to think about how these miniature marvels are made? The process is as fascinating as the technology itself. It begins with raw materials, primarily silicon, which is abundant in sand. This silicon is purified and transformed into wafers, which serve as the foundation for microchips. The journey from a simple grain of sand to a sophisticated microchip is a fascinating one, filled with ingenuity, precision, and a touch of magic. Each step in the manufacturing process is meticulously controlled to ensure the highest quality. Engineers and scientists work together, pushing the boundaries of what is possible, to create these tiny powerhouses that drive our world. So the next time you use your smartphone or start your coffee maker, take a moment to appreciate the incredible technology that makes it all possible. It all starts with sand, but not just any sand. The sand we're talking about is not the kind you find on your average beach. This sand is special, and it plays a crucial role in the technology that powers our modern world. The sand used to make microchips is rich in a substance called silica, which is the basic ingredient for making silicon. Silica, or silicon dioxide, is found in high concentrations in certain types of sand, making it the perfect starting material for the high-tech processes that follow. Silicon is a semiconductor, meaning it can conduct electricity under certain conditions, which makes it perfect for creating the intricate circuits within a microchip. This unique property allows silicon to act as the backbone of the electronic devices we use every day, from smartphones to computers. The journey from sand to silicon begins in massive factories where the sand is heated to incredibly high temperatures. These factories are equipped with industrial furnaces that can reach temperatures of over 2,000 degrees Celsius, necessary to melt the sand and initiate the transformation process. This process removes impurities and leaves behind pure, sparkling silicon. The molten silicon is then carefully cooled and solidified into large cylindrical ingots. These ingots are sliced into thin wafers, which will eventually become the microchips that power our devices. This purified silicon forms the foundation upon which the complex world of microchips is built. Each wafer undergoes a series of intricate processes including photolithography, etching, and doping, to create the tiny circuits that make up a microchip. It's amazing to think that something as ubiquitous as sand can be transformed into the building blocks of our digital age. From the humble grains of silica-rich sand to the sophisticated microchips that drive our technology, the journey is a testament to human ingenuity and the incredible advancements in materials, science, and engineering. Imagine a giant washing machine, but instead of clothes, it's filled with molten silicon. That's essentially what happens next in the microchip making process. The purified silicon is melted down into a liquid form, and then it undergoes a series of chemical washes and spins. These washes remove any lingering impurities, leaving behind silicon that's cleaner than a whistle. This extreme level of purity is crucial because even the tiniest speck of dust can ruin a microchip. Think of it like baking a cake. If you use dirty ingredients, the cake won't taste as good. Similarly, impure silicon can disrupt the delicate circuitry of a microchip, rendering it useless. Once the silicon is squeaky clean, it's time to shape it. The molten silicon is carefully poured into cylindrical molds and allowed to cool. This creates large, solid blocks of silicon known as ingots. These ingots are then sliced into incredibly thin disks, much like a loaf of bread being sliced into pieces. These thin disks, called wafers, are the foundation upon which individual microchips are built. The wafers are polished to a mirror-like finish, ensuring a perfectly smooth surface for the intricate circuits that will be etched onto them. Each wafer can hold hundreds, even thousands of individual microchips, depending on their size. Now for the artistic part. The process of creating the intricate circuitry on a microchip is called photolithography. Imagine using a stencil and light to create a pattern on a surface. That's essentially what happens during photolithography, but on a much smaller scale. A light-sensitive material called photoresist is applied to the wafer's surface. Then, a pre-designed pattern of the chip's circuitry is projected onto the wafer using ultraviolet light. The areas exposed to light harden, while the unexposed areas remain soft. The soft areas are then washed away, leaving behind the desired circuit pattern etched onto the wafer. At this stage, the silicon wafer has a pattern etched onto it, a crucial step in the semiconductor manufacturing process. This pattern is created using a technique called photolithography, where light is used to transfer geometric patterns from a photomask to a light-sensitive chemical photoresist on the silicon wafer. But it's still not a functional microchip. The etched pattern serves as a blueprint for the subsequent steps, but on its own, it doesn't have the capability to perform any electronic functions. To turn it into a working electronic component, it needs to be doped. Doping is a critical process in semiconductor fabrication that involves adding specific impurities to the silicon wafer. Doping is the process of introducing impurities into the silicon, which can be elements like phosphorus or boron. These impurities are introduced in very controlled amounts to alter the electrical properties of the silicon. This process changes its electrical properties, making it possible for the silicon to conduct electricity in a controlled manner. The impurities create free charge carriers, either electrons or holes, which are essential for the semiconductor's functionality. By carefully controlling the type and concentration of impurities added, engineers can create regions within the silicon that act as conductors, insulators, or semiconductors. This precise control is what allows for the creation of complex electronic circuits. Engineers can design these regions to perform specific functions, such as amplifying signals or switching electrical currents on and off. This is the foundation of modern electronics. This allows them to create transistors, the tiny switches that control the flow of electricity within a microchip. Transistors are the building blocks of all modern electronic devices, from smartphones to supercomputers. The ability to precisely control the electrical properties of silicon through doping is what makes it possible to create these incredibly small and efficient transistors. It's like adding different spices to a dish to enhance its flavor. Each impurity added to the silicon enhances its ability to conduct electricity in specific ways, allowing for the creation of highly specialized electronic components. Doping enhances the silicon's ability to conduct electricity in specific ways, enabling the creation of advanced microchips that power our modern world. This process is fundamental to the development of all electronic devices, making it one of the most important steps in semiconductor manufacturing. With the circuitry etched and the silicon doped, The individual microchips are almost ready. But first, they need to be thoroughly tested to ensure they function correctly. Specialized machines scan each chip, checking for any defects or errors in the manufacturing process. It's a rigorous process, and only the chips that pass all the tests are deemed fit for use. Any faulty chips are discarded to maintain the high quality and reliability that microchips are known for. This meticulous testing ensures that the microchips that end up in our devices are dependable and perform as expected. The final stage in the journey is packaging. The individual microchips, now fully tested and functional, are encased in protective packages for safety. These packages provide physical protection and electrical connections to the outside world. Think of it like putting a delicate electronic brain inside a protective helmet, with wires extending out to connect to other components. The package protects the delicate chip from damage and allows it to be easily integrated into various electronic devices. The impact of microchips on our lives is undeniable. They are the unsung heroes of the digital age, powering everything from the smartphones in our pockets to the most sophisticated computers in the world. Microchips have revolutionized communication, entertainment, transportation, medicine, and countless other fields. They have made devices smaller, faster, and more powerful than ever before. From the Mars rovers exploring the Red Planet, to the medical devices saving lives, microchips are at the heart of countless technological marvels. The journey of microchip creation is a testament to human ingenuity and our relentless pursuit of technological advancement. As technology continues to evolve, so too will the microchips that power it. We can expect to see even smaller, faster, and more powerful chips in the future, opening up new possibilities in artificial intelligence, robotics, and beyond. The future is bright and it's powered by microchips. As we continue to push the boundaries of what's possible, one thing is certain. The humble microchip, born from a grain of sand, will continue to play a pivotal role in shaping our world.